just gonna show you a few cool things. Okay, let's see if this works. So this is a kitchen scale. It worked this morning. It worked this morning. So let's see. There you go. Oh, you can see that. That's a kitchen scale. No way. You can't tell what it is, right? Is that because of the blue screen? Is there like a way around it? Come on, one of them will have to work. Oh my goodness. I thought I had it all figured out. You can't tell at all, right?
I think I saw it for a second.
Oh, there. If I move it quick like that. Oh man, that's pretty funny. That's pretty funny. What's that? Angle? Let's see if Dino's gonna save the day here. Ah.
Nope, you got the wrong wires.
Okay. That's really too bad, but oh my goodness. Because this would be so perfect for, let's pause the video because I don't want to be all, there you go. 0.538, right? Can you see that? Okay, so what's the precision of this thing? 0.001 of a kilogram. So this, I tried it this morning. Let's see how much is going up by. Oh yeah, oh, it does the 0.02. Anyways, it's more, but what just happened there? Like, why did it round? Because it's 5.38. I throw this sticky note on there. First it's 9, now it's 40. What's happening there? Joey, it's the uncertainty. Like if you could add another 0, it'd probably give you what it is, but it can't give you that, so it needs to do what? It needs to round, up or down. It needs to decide, right? So it's not like this thing is getting heavier. It's just like, oh, wait a minute. So in the background, it's happening. And then it's like, okay, now it's still, boom, we round it, right? So that's what's happening there. And this thing has various options. So units, I could change it to ounces, pounds and ounces if I wanted to. I don't know if you see that. You can probably not see that very well. Fluid ounces, milliliters. I can even do milliliters if I wanted to. I don't know if you can see that. Grams. Right now I'm in grams, just plain old grams, not kilograms. So if I do grams, it's 538, 539. Okay, it's a little bit more. It's able to get it closer. So anyways, so that's precision there and the uncertainty that creeps up on us, right? So I'll put this away. Now I'm going to do another one. If you have an electrician as a family member, you probably, or you might have tried one of these before, just so you can test voltage and amperage. Voltmeter, there you go. You actually know the name. Even better, because I drew a blank there. It's a voltmeter, exactly. So let's see if this works. So there, let's try that first. So trying one of these AA batteries, you know the voltage of those? Anybody? It does say it on the battery, so let's read it. Can you see that? See it? 1.5 volts. That's the target. That's what we're aiming for. Let's measure it. Red usually goes on the positive. 2. What's going on? Didn't it say 1.5? Okay, let's is this very precise? It's down to nearest volt. Let's add a decimal. You saw that popping up there? Let's try it again. Oh, it's 1.6. But before it didn't know, like it couldn't show you. So it just say, hey, I can only give you the voltage to the nearest volt. So I had to go to 2, right? Because it's rounding. Now it's 1.6. Let's do one better. 2 decimals now. So now we're down to the nearest 0.01 of a volt. It's 1.62, right? So the precision is getting better. The uncertainty is getting smaller, right? The more decimals you have. Doesn't this blow your mind? It should. This one is not going to work. This one is actually a 9-volt battery. If you put your tongue on it, you'll feel it. I don't know if you've ever tried it when you were younger. My cousin told me, hey, you want to do this? It's like, oh yeah, sure. Right? It just don't do it. It's actually pretty scary. It won't kill you, but it really gives you a zing, a zap. So let's see here. 7.23. This one has an 24. It is an old battery. So I used it already. I was gonna recycle it, but I brought it in. So it probably was originally in the 9 something, but it's not. The next one, don't try this at home. What's the voltage on our outlets?
Oh no.
What is it normally? Anybody know?
Why would it?
Nobody knows?
You can test it.
It's technically supposed to be 110.
That's too much.
110 volts, okay? I do this all the time, but you don't do it, okay? If you're watching this, don't do it at home. So wait a minute, what kind of current? This is direct. Anything with a battery, your car is called DC, direct current. Anything in your outlet is called it's AC, alternating current, meaning the positive and the negative constantly switch back and forth. That's because it's made out of hydroelectric.
Oh,
It's not. It's all going to be good. Like I've done this many times. So put one in there. What do we get? 113.5. Didn't I just tell you it's 110? Most of your electronics will say 110. Okay, it's 113.4, 0.5, 0.4, 0.5. It's just fluctuating. Okay, I'm just gonna leave it at that. I could probably do more. Like if I gave it just no decimals here, this is just the nearest volt. It'll probably be just 114, 113, right? Because it has to round to nearest volt. So never put your finger. Very careful with that. Don't do this at home. This is just for illustration purposes. So I just wanted to give you a really good, pretty good idea of how precision, how that actually works. It's actually a thing. You just don't think of it, right? All right, page 93. Let's go to 93 here. Okay. And 93, we talked about tolerance. I need you to understand this because if you don't get it right off the bat, you're going to be confused. Uncertainty is just what happens when you're trying to measure something. You could be off by a bit. That's uncertainty. It's the margin of error, right? Tolerance is it's telling you what is acceptable, like what is acceptable. Because of the uncertainty, there's always a little bit of fluctuation. So the industry tells you only something between here and here is acceptable. So the range of values is acceptable. So I encourage you to add this to your study sheet, right? Tolerance, you can subtract the min and the max. That's one way of doing it. But this is probably the better one here. This is the definition. The other one was just how would you find it numerically. The measurement variation allowed so that an item is acceptable, right? Or the range of sizes that are acceptable. Or again, the range in acceptable values. So the range is the difference, okay? So keep that in mind. Let's go back here. I gave you some examples yesterday. So we're going to go through the 4 ways of stating tolerance, okay? The first one is the max and the min. Like if it's like this, you know it's this format. You should have that on your study sheet, okay? All 4 of these. And then I told you that from every single one, you should be able to extract 4 pieces of information: the max, the min, the tolerance, and the nominal. Okay? And so we filled that in. And the one thing here, the nominal, we're assuming that it is halfway between the min and the max. But I will not on a test ask you to do this. Okay, I will not ask you for the nominal when it's like this. On worksheets, you might see that, but in reality, that's not true. It's not always halfway, okay? Then we did the second method, which is nominal value plus or minus half of the tolerance. So you should be able to recognize it. Basically, if you see plus or minus and the half there, you should recognize, okay, we're talking tolerance. And again, min, max, tolerance, nominal. You automatically take this and fill in the nominal. When it's written like this, you know exactly what we're aiming for. Nominal is the target. Tolerance is obviously inside the brackets. The min and the max we had to calculate. Min is the nominal minus half of the tolerance, right? So we actually did the whole math here and came up with that. I will show you a quicker way of doing this today. The max, we take the nominal, we add half of the tolerance, and we get this. So we were able to get min, max, tolerance, and that. Now it's another example here. Make sure you write this down. So let's say you have 5 degrees Celsius, and you get a minus 0 Celsius here, and a plus, no, sorry, yeah, we're good. 2 degrees Celsius like this. So write this down. If you get something like this, and you see the minus 0, it's like, where's the 0 again? It's down here. So this is then my minimum. So let's write down the 4 things we can extract: max, min, tolerance, and nominal. So this number right here, because we have a minus 0, we can't get any lower, right? Like this is your min. So we're going to go over and say right off the bat that the lowest temperature is 5 degrees Celsius. That would be acceptable. And watch this. It also is our nominal. That's what we're aiming for. It is both. When you get one of these, you're going to realize that it is both. Okay. What's my max? Well, it's simply going 5, right? You take the nominal and you add the 2 that is up here. It tells you to add that. So the max is 7 degrees Celsius. And the tolerance, can you just trust me on this? I know you might be tempted to just grab that number, but I'm actually going to go max minus min, because that's what we've been telling ourselves all along. 7 minus 5 is 2 degrees, because it's not always going to be. Trust me for now, okay? I'll show you an example where that is not the case. Let's do another one. Let's say you have 0.5 milliliters. And this goes minus 0.1 milliliter plus 0 milliliters. And we're going to go max min. It may not always be in this order. So don't be like, it has to be in this order. So let's say this is Monday morning, you forgot, like, what is max again? How do I do max? Even if you forgot, you're just gonna do this 0.5 plus whatever is here, which is 0, right? So I actually took this and I got the max there. And this is the part where you have to just wrap your head around. It is also what we're aiming for. It is both. So when you have it in these formats, that first number will be the min or the max, depending on the situation, but definitely our nominal. Okay. Minimum, we just take the 0.5 and we subtract the number that it's telling us to subtract, right? Which is 0.4 milliliters. Tolerance, we go max minus min, which is 0.5 minus 0.4, which is 0.1 of a milliliter. Can you imagine the headline if that experiment with the 110 had gone wrong? Like, teacher gets zapped in front of class during a math lesson. Anyways, 45.05. One last example that is a little different. You really wanted us to learn the concept of precision and uncertainty. All right. What's so different about this one, Joey?
You don't have like
Right. There's no zero anywhere. Do you notice that? Minus something plus something. It's like, what? Right? So that's what you know though for a fact is you park this in the nominal for sure. That's what you're aiming for. That first number is always what the industry is saying, hey, we want this if at all possible. But there's acceptable range, right? So to get the max, you take the 45.05 and you add the top number, right? Like, because it's saying to get the highest acceptable value, we just add, and that's 45.07 centimeters. To get the min, we're going to have to subtract. So it's just arbitrary, random, but the industry, whatever you're working, whoever you're working for will tell you, right, this is what we expect. So anywhere between these two is okay, right? So that's where tolerance, where I told you take your max, subtract your min to get that, because it's not nowhere in here. The tolerance is neither one of these numbers. So 45.07 minus 45.02, which is 0.05 of a centimeter. Okay. this page is like one of the most important pages for tolerance. Like if you have this down, if you have these examples, notice that this one only has one arrow to immediately fill in. In fact, if you have a highlighter ready to go, because I asked you to have one, I will do this. I will highlight the front number and make sure you see it in the nominal category. I will highlight this front number and make sure you see it in the nominal. Because if you can fill in one right off the bat, it's so much easier. In fact, the nominal, you don't need to really, for these, you don't need to do any work. You just need to state it. So that front number found its way in the nominal here as well. So it may be something else as well, but it definitely is what we're aiming for. That's what we're targeting. Okay. All right. So let's see. Go with me over to 94. It's a blank page there. And what I was thinking of adding here is tolerance. I'm kind of going to put my own spin to it a little bit. Obviously, we're going to go with range of acceptable values, right? Item measurements that fall between the min and max, right, will be accepted. Example, let's say you had a 2.1 millimeter and a 1.7 millimeter min and max. If you had a piece that measured 2.0 millimeters, it would be accepted. 2.1 millimeters, it would be accepted. 2.15 millimeters, it would not be accepted. 1.6 millimeters would not be accepted because it's below, right? So it has to fall within the specified tolerance, the acceptable values. Okay. Examples: prescription drugs, right? Dosage has to be high enough to have an effect low enough to not cause an overdose. Something like that. A door has to be small enough to fit, but it can't be too big because then it wouldn't be, yeah. Right about there. Okay. I feel like I messed with the blue light a little bit, like something isn't right. It's like a hue or something. Uncertainty is the margin of error It is caused by limitations of measuring device. Believe it or not, that does say uncertainty. You might not be certain, but it is certainly saying uncertain. Okay. I think I'm going to get you to work on the tolerance worksheet that I made. And I made it so it's not part of your booklet because I found that none of them were really targeting that. So if you're nice and quiet, you get the rest of the day to yourself, the rest of the period. The first couple of questions, they go back to precision and uncertainty with, I wanted some diagrams. And notice that some questions, they ask you to measure this thing, like to actually come up with a measurement plus or minus the uncertainty that you had there. So it's not just precision uncertainty. Some of them you'll have to you have to kind of guess, right? Your best guess. Put it down here and plus or minus the uncertainty. So some of them do have it, some of them don't, right? Like this one has nothing to measure, so there's nothing other than precision and uncertainty, nothing else required. If you go to the back side, this is where really today's lesson is focused around. In each of these cases, right, I give you the different ways of stating your tolerance. I want you to give me the max, the min, the nominal, and the tolerance. So make sure you also make it through there. And then this is doing the exact same thing. And then using these, I'm going to ask you to state the tolerance in 3 different ways. And I actually tell you exactly what I want them to look like. So it's kind of like once you have this filled out, you can go every which way. Just take, plug in, and go, right? So that's what you're supposed to work on